Hello everyone, welcome to our fourth week with programming with C++ lessons, and today we'll be talking about expressions and statements. Talking about expressions and statements, how they work and how to use them in your code. You'll be needing them as a programmer. So let's move to the objective. Our objectives, you understand statements, the type of statement, expressions, and the types of expressions. To move on, let's begin with expressions. Someone will be like, what's an expression? So simply, an expression is simply a combination of three things, and these three things are variables, operands, and the operators. Some will be like variables. We've discussed variables, operands, and operators in our previous lessons, but let me briefly go through for those who just join us. It'll be like the variable stores values or results of an expression. The variable stores values or results of an expression. The operand are the actual data that operators work with. The operands are the actual data that operators work with or they act on. It represents the data in an expression. We have operators. The operators are also the mathematical symbols used for specific operations. These are the operators. So like the plus sign, there's subtraction, division, modulo, they are all the operators. And the operands are like, let's say when you give an example as 2 plus 3, the operands are the 2 and the 3. These are the operands, and the operators are the plus sign that we have been using as an assignment. And we move to a special example. So let me give you an example to make this thing clearer. When we say a plus b, we like a plus b. The a plus b is an expression where the a and b are the operands. Yeah, the a and b. When we say a plus b, as you see here, the a and b are the operands, and the addition sign is the operator. The addition sign is operator. So I have the C. The C is also an expression. It's just a single operand with no operator, but it's also an expression. Yes. As in English, would be like you. Yeah. You, I, we. They are all sentences. We consider them as words. Yeah, that's the same thing for program. C is also an expression. And we have x equal to a plus c. In this situation, we are assigning the result a plus c to the variable x. So here there's something important that you have to remember, that an expression can have one or more operands and it can have zero or more operators. The key is that it always produces a value. So here the x is our variable. It's storing the a plus c. How we get it? It's storing the a plus c. Let's continue with the types of. So here we also have the a plus b. You see the plus as the operator, the a as the operand 1, the b as operand 2. Yeah. So when you have something like x is equal to a plus b, meaning the x will be our variable in this context. But we don't have a variable here. We have operands and operators here. So you should take note. We are coming to types of expression. Now let's talk about the different types of an expression you will encounter on your way as a programmer. There are several categories, and understanding these will help you write better codes. So the main types, we have the constant expressions, the integral expressions, bitwise expressions, the logical expression, pointer expression, relational expression, floating, and many more. And let's take them one by one. If all operands are integers, the expression is called an integral expression. So when you talk about integral expression, it uses only integers. If all the operands are integers, then we call that expression as integer expression. Then we have the operand, the floating point expression. It's used decimals. It's used decimal 5.5, 2.3, something like, instead of a plus b, it will be like 2.3 plus 5.5. That's a floating point expression. That's a floating point expression. And we have the mixed expression. So a floating point expression yields a floating point result. We have the mixed expression. The mixed expression have operands of different data types. So the mixed expression can contain both the integers and floating point numbers in the same expression. An example can be 2 plus 3.5. The 2 is an integer, the 3.5 is a floating point. So when you see such a thing, it's a mixed expression. That's what we mean. We have the conditional expressions. Expressions where the value produced depends on the value of a condition. That's what we call the conditional expression. So think of it like asking a question. If this condition is true, use this value. Otherwise, use that. That's a conditional expression. And we have the relational expression. Relational expression is in the form of comparing two values and giving a true or false answer. That's a relational expression. They always produce a Boolean result. This data type that the Boolean data type, which is the true or false Boolean. So an example is what is on our slides: x less than or equal to y, x plus y is greater than 2. That's an expression. That's the relational expression. You have the logical expression. The logical expression combine multiple relational expressions using logical operators like the and, the or, and the not. The and is the addition, the or is multiplication, and the not is the inverse. So they also produce the true or false statement. An example is if x is greater than y, x is greater than y, and x is equal to 10. And the second example, you have x is equal to 10 or y equal to 5. Yes. We have the pointer expressions. As you continue, you're continuing with the pointer expressions. Pointer expressions produce address values. They work with memory addresses. Don't they work with memory addresses? So an example is the ampersand x. So this gets the memory address of variable x as the first example. As you can see here, this ampersand x, this gets the memory address of the variable x. And we have the pointer itself, this ptr, this is a pointer variable. And we have ptr plus plus as this. This moves the pointer to the next memory location. That's it. You have the ending. Let's move to the next slide. Ending an expression. Our next topic is ending an expression. How do you understand by ending an expression? This is something crucial here. Every expression in C++ must end with a semicolon. That's what we call terminating. If you are terminating it, you terminate with a semicolon. It tells the compiler that you are done with the expression. That's what we mean, ending an expression. So semicolon is used to mark or show the end of an expression. Let's see an example here in our slides. So an example is this. This is the basic structure of our C++ programming language. So here, this is our code. We've terminated it with a semicolon. We've ended our expression with a semicolon. Here, this is a string with the double quote. Ended with a semicolon. If you don't end your code with a semicolon, your code is not going to run. So you should take note. If your expression is not ended with a semicolon or it's not terminated, your code is not going to run. You are going to face an error. That's what's going to cause stress. If you don't know anything about it, you can put a whole code on a sheet. If there is no semicolon, even a single line, your code is not going to run. You should take note of this. So terminating your expressions are very, very important. Terminating your expressions are very important. So you should take note. That's the semicolon. Terminating your expressions are very, very important. The semicolon. Let's continue. Let's move to comments. When we talk about comment, what are comments? That will be like comments. Comment is used to make reading and understanding programs more pleasant. Comment are notes you write as a programmer. The comments will be like your note that you're writing your code, so you don't forget anything in case of anything that the computer ignores. The comment, they are notes that you programmer you write, but the computer does not write that comment. The computer does not run your comments, but they are notes that you write in your codes for easy understanding. Easy understanding. That is for human to read and understand the code that you've created. So the importance of comments are like making your code easier to understand, explaining. It explains the complex logic that you've written. So you the programmer, sometimes you can write some code that you know this one by 3 years, 5 years later. you want to remember, because as time goes on we are still learning new things. So you put on this comment as your note, so that later in future when you come back for your code, you know that yeah, this is what I was trying to do here, this is what I was trying to do here. That's why we write the comment here. That's why we comment in our codes. Comments are used for easy debugging. If you want to make a change in your code, it's so easy. You just go straight to where you made a comment, then bah, just make the change. Now moving to how do you comment? Now someone will be like, so if that is the case, then how are you going to make a comment? We have like two types of commenting. We have the single line, then you have the multiple line. So let's think about the single line. The single line is we applies comment to a single line only. The single line comment applies to only a single line. The compiler ignores any text after this sign. So we use this symbol. This is a double forward slash. We use the symbol double forward slash for single line comment. We use the single double forward slash, which is highlighted here in our slides. That's what we use for single line commenting. Let's see an example down here. So as you can see in this slides, we've commented this, and all codes that are commented, all the codes that will be within the comment will be of different color. Most of the times it's in black form, as you can see here. They'll be different from your normal code. The color that will be highlighted will be different from your normal codes. You should take note. So this is see out hello world, but this symbol is used to comment on a single line. So let me see if I'll get an example for you. Then we will continue with our multiple line comment. For the multiple line comment, you have to begin and end your code. It can span multiple lines. They start with multiple line comment. You start with this, then you end with this. I hope you are getting it. Multiple line comment. They start with the forward slash asterisk, then it ends with asterisk forward slash. So the compiler is going to ignore all the text within this comment. The compiler will ignore all the codes block within this comment in the spaces that you've provided that you are commenting. So let's continue to an example here. So this is an example. When commenting this, we begin with the forward slash asterisk, then this is the first line, this is the second line, then we end with the asterisk and the forward slash again. That's a double or multi-line comment. It can be more than 3 lines, 4 lines. It can even be the whole code. Yes, it can be the whole code. And you should also take note when you start with this, it's going to highlight the whole code. But don't forget that you should end it. You should end it at where you want to comment. If not, the whole code are going to be commented, and you run, and nothing is going to run. You should take note. Let's continue to indentation. We talk about indentation. How do you mean? How do you understand indentation? Indentation is in the form of like spacing your code, spacing out your code, making the code neat and readable. It's like organizing your room. It doesn't change how things work, but just make it much easier to understand. That's what we call indentation. That's what we call indentation. So it makes your code readability, and understanding much more pleasant. Each nested block should be properly indented and spaced with a tab space. Sometimes some IDs like Visual Studio and code blocks, if your indentations are bad, your code are not going to run. If you don't indent your code, some of the lines are not going to run. So you should take note. And all the braces should also start from a new line. Then the code comes following the end braces. The curly braces, you should begin your curly braces also from a new line. So let's see. So the indent is mainly used for code inside looping. Our indent are most of the times used for code inside looping. Then it can be used in functions when the loops and control structures are used in them. That is the indentation. So this is an example of an indentation. You see, we have hashtag include iostream here. It follows using namespace. You have the int main. They are all on the same line. But when we come within the code, which is the int main, this is the our curly braces, and we have the int a equal to 5, b equal to 6. Below it, beneath it, we have the if this. They are also indented in a different style from the first three, which is the structure of the code blocks. And you can also see we have the C out, which is the output, which output this. We have it here. So this is how your code should be indented. Yeah, that's what we call indentation. Now, other with expression, let's move to statements. Why we say statements? How do you understand a statement? A statement is a single instruction that tells the computer to perform an action. So a statement, single instructions telling the computer to perform an action. They are like the building blocks of a C++ program. That's a statement. Everything your program does is made up of a statement. You should take note. Let's move to the types of statements. So when we talk about types of statement, we have the selection statement, which is statement used in decision making. Example, the if, the switch. You have the iterative statement. It's used for repeating tasks. Iterative statements are used for repeating tasks. An example for while, do while. And we have the expression. So you can see the examples are here. When you go through the slides or you go back to the video, you can get all these slides. I'll also share the link within the comment section and you download the slides from there. We have the expression statement, which are the statements used to evaluate expressions. And expression statement. We also have declaration statements. Statements used to introduce new variables or constants. That's the declaration statement. Example, int age. And we also have the jump statement. So a jump statement are statements used to manipulate normal execution of codes. That is jump statement. It's used to change the normal flow of the execution. We have the compound statement. So we have the compound statement. Statement that group multiple statements together. So compound statement is to group multiple statements together. They are a block of codes enclosed in curly braces. As you can see here, this is an example here. Int a equal to b, int a equal to 10, int b equal to 20, then you see out a plus b. That's compound statement. We have selection statement. So statement used for decision making C++. So when we are going through our statements one by one, we are taking them one after the other. So you have the selection statement. Selection statement helps your program make decisions. They are like asking questions. If this condition is true, do this, otherwise do that. That's the selection statement. So the main selection statement are the if statement, if else statement, and switch statement. That's the main selection statement. So you should also note a condition is either an expression or a declaration. A condition is also an expression. It's either an expression or a declaration. So these are the structures of the selection statements. So decision making statements in C++, we have the if else, and the conditions are the true or false. You have the switch here. So you have the if else, the if, then you put in your condition. You have the if condition, then you have else. So if it's not A, then it is B. Then you have the if else if condition. You have the nested ifs, you have the switches. Yeah. They are all selection statement examples. So now when we go through the slides, you reading through the if statement and how they are being used, a mechanism for deciding whether an action should be taken or not. This is the if statement we have here. We're dealing with, we'll move that deeper in our as we are progressing or we are moving on with our lessons. So let's go. I'll just be reading the definitions to the later we do it practical aspect. So you have the if statement. There's an example of the if statement. You can try it on your own. You have the include iostream using namespace std, int main. You have int age equal to 20. If age, this is the if statement. So if age is greater than 18, then you should output students can vote. Then you end your line. This is an if statement. So an if statement, all the code should use indentation. So if statement using an indentation, there is it. We also have if else statement. The if else statement can be used to choose between two conditional statements. So if the statement is not A, then it should be else it should be. If the statement is not true, then the output should be false. That's the if else statement. So if the int age is equal to 2, so here in this code, the age is equal to 12. So now if age is greater than 12, the student is old. So if age is not greater than 12, then output the student is young. Anything below 12, you should output the student is young. That's the else. And nested ifs. The nested if statement can be used to choose between conditional statements with nested conditions. So you have the syntax is if expression, then statement. There's an example we have. Sometimes you need to check multiple conditions. So we have if n is greater than 0, then n modulo equal to 1. Positive odd number, as you can see here, nested if statement, switch statement. Have the switch statement that allows you to choose between multiple alternatives, compare the values of one expression with multiple constants. So expressions in switch statement must be an integral type, that is integer, character, boolean. So you are scrolling, you move to this is an expression of the switch statement. You'll be diving deeper into it. So break statement, you have the break statement. The break statement exists from a switch or a loop immediately. Break keyword can be used to jump to the first statement that follows a switch or a loop. So it is an example of a break statement. You move into the next line and you are breaking to the next line. That's it. Continuous statement. The continuous statement, continuous execution after condition is accomplished. It is used in loops and has opposite effect to break, and that is the next loop is to begin. Continuous statement, this is an example. Continuous statement. Then operators. Operators are mathematical symbols used for specific operations. That's the plus, subtraction, the question mark. They are all operators. Then the type of operators, you have the arithmetic operators, assignment operators, we have the conditional operators, relational operators, we have the logical operators. Let's see them one by one. So for the arithmetic operators, we have the plus, subtraction, multiplication, division, the remainder, which is called the modulo operator. So they can be used for integral and floating point data types. Yeah, with the logical operators, it's used to express logics, to return a bool results. It uses the and, or, and not operators. Not operators. So we have example x and y, x or y. The logical operators, you have the and. And uses this symbol. You can see this is the end here. And we have the or statement. This is the or statement. So the or is addition and is multiplication. You have the not. You have the not statement here. Conditional operators. The conditional operators is used to form an expression that produces either of two values depending on the value of some condition. Conditional operators. It's an example of a conditional operator. You have increment operators. So used to express increment in a value. So it can be used as a prefix or postfix operator. This is this as an increment. This is an increment. That is the sign that we use for increment. To take note, prefix is increment and postfix increment. You have the decrement. It's the opposite or the inverse of the increment expression. It's the same idea, just the opposite, and the sign is two subtraction signs. That's all. Talking about here, we'll be talking about our operator precedent. All operations inside of this bracket are evaluated first. That we have come, then we'll come to this. But it's just go through the note and you understand. So our before tax or assignment, we have using the knowledge from week 1 to week 4. Students are to build the GPA calculator and the DEX calculator. Let's recap what we've covered. We learned about expressions and how they combine variables, operands, and operators. We explored different types of expressions from simple arithmetic to complex logical expressions. We also covered operators and how they work with data. We learned about proper code formatting with indentation and comment. Remember, programming is like learning a new language. The more you practice these concepts, the more natural they will become. So don't worry if everything doesn't click immediately. That's completely normal. For next week, make sure you complete the GPA calculator and the desk calculator assignment. This will help you solidify your understanding of expressions and statements. Thank you for your attention, and I'll see you next week where we will dive deeper into control structures and loops. Keep practicing and don't hesitate to ask questions if you need clarification on any of these concepts. Thank you once again. I am Emmanuel Asare, and I'll be a lecturer from week 1 to week 10 for now in programming with C++. Thank you. Bye.